Welcome to solverfy.
So in this problem, we have a hydrogen atom which is excited from its ground state to state n is equal to 4. We need to find out how much energy must be supplied or must be absorbed by the atom to do this. So the first part is where we need to find the delta E that is required to make a transition from 1 to 4, and that can be calculated as equal to 1 over 4 square minus 1 over 1 square, where we have used that E of n is equal to minus 13.6 over n square, and this is exactly equal to 12.8 EVs. So 12.8 EVs of energies should be absorbed in order to make a transition from 1 to 4. Now the second question is how many transitions are possible as the atom de-excites to the ground state. Now you will notice that we can draw all the transitions, so I'll quickly draw all the transitions. Imagine these are the 4 levels, 1, 2, 3, and 4. So how many transitions are possible? You can make a transition from 4 to 3. You can make another transition from 4 to 2, or you can make a transition from 4 to 1. However, we can also make a transition from 3 to 4. So the electron can make a jump from 4 to 3 and then from 3 to 2, or it could make directly from 3 to 1. And if it comes to 2, it can make a transition from 2 to 1. So we have 1, 2, 3, 4, 5, 6. So we have total 6 transitions which are possible. Now we need to find out the energy of the highest, how many different energies are possible. Total 6 energies are possible. Which is the highest, second highest, and so on. So we'll find the highest. So highest will be between 4 and 1. And that is when you make a transition from between 4 to 1, that gives us the highest, and that is exactly equal to 12.8. Next we need to find out the second greatest energy. That should be between, as you can see, 3 and 1. So 4 and 1 is the largest, and then 3 and 1. Again we can do this calculation. 13.6, 1 over 3 square minus 1 over 1 square, and that is equal to 12.1. Next we need to find the third greatest energy, and that should be between 2 and 1. So if you make a transition from 2 to 1, the energy of this comes out as 10.2 EVs. For F, we need to find out the smallest energy. The smallest energy in this case will be between when you make a transition from 4 to 3, because as you go higher and higher, the energy difference between adjacent levels keeps reducing. So the difference between 4 and 3 is the shortest of all. Then it will be between 3 and 2, and then 1 and 2. So 4 and 3. So this is E4 to 3. This is the shortest of all. Energy here is 13.6 as usual into 1 over 4 square. So I'll write this as 4 to the power negative minus 1, negative 2, and 1 over 1 square can be written as 1 to the power minus 2. This is 0.661 EVs. Now we need to find the second smallest. So the second smallest in this case is between 3 to 2. And the energy of this is, on similar lines, 1.89 electron volts. And the final is the third largest. So the third largest is between E from 4 to 2. If you feel that there is any other transition in between which is smallest or largest, you should plug in the values and check that this will be actually the third smallest. 2.55.